Hello everyone, welcome back. Today's video is on subsurface waters. The learning outcomes of today's video is to define groundwater and the zones that compose sort of our subsurface system. And then we're going to define recharge and discharge, sort of when water starts moving between these two. And so what we've learned so far has been looking at the surface water flowing over the surface of the earth. But in actuality, rivers and lakes represent sort of a connection with groundwater and sometimes are actually sort of the protrusion of our water table through the surface of the earth. As in this case, you see our water table line that goes across here. This lake is actually the water table poking its head through the surface of the earth, which is pretty cool. So everything is actually connected. Is no river or groundwater aquifer. They're all sort of a part of the same water reservoir. And so our groundwater zones are composed of a saturated zone and an unsaturated zone. And so your unsaturated zone is on the top here. You have in the yellow, that is the part where the sediment is not filled with water. The saturated zone is saturated with water. The sediment is completely filled with water. All of its pore space is filled with water. And that composes an aquifer. Aquifers are nothing but water stored in sediments. And so the boundary between this two represents the water table. So when you hear people talk about the water table, this is what they're referring to. It represents an elevation. And so when we drill a well, we'll get a reading of that elevation with reference to some datum, maybe the bottom of our frame here, the bottom of the confining bed. And so when we drill in and we get a reading, and over here it's maybe 30 feet, and at the stream or lake it's about 20 feet, you can see there's a difference. There's a elevation head difference, and water likes to flow from highest points to lowest points. And so there's going to be a natural flow of water into our stream or lake here because of that difference in elevation. It's like a lake. If a lake wasn't confined to some vessel, it's able to be some sort of structure, a big blob where it's actually changing in X and Y, but also in Z. There's parts of it that are on this side and in a higher elevation than other parts of the surface. So having the water table be able to represent different elevations over a distance is a really interesting part of hydrogeology and where a lot of the interesting behavior comes from, because it's not just a flat surface of a lake, it's more complex than that. And so some sediment layers are able to take in more water than other sediment layers. And these form reservoirs called aquifers. And so sediment is not homogeneous under Earth. It is layered in different depositional layers. That's what forms our sedimentary rock eventually. None of these are rocks yet, but there's different types of sediment that have been deposited, which will carry sediment in different ways. And so I want you to think, what porosity of sediment is going to accept more water? And that's highly porous sediment is going to accept a lot more water, whereas really low porous sediment that's able to compact a lot more, there's not a lot of pore space, it's not going to be able to accept more water, and it's actually going to behave more like a solid block, a solid material, an impenetrable layer than an aquifer that is able to accept water and have water distribute evenly through it. And so less porous sediments have less void space, and these can actually form caps in the sedimentary layers, and that creates aquifers that are confined. So this aquifer down here at the very bottom is actually not touching the surface. It's forming its own layer of water that's separate from all the other layers. And so this is called a confined aquifer because it's confined by a confining bed. And a confining bed is sediment that has low porosity. Low porosity. It doesn't mean it has no porosity. It's still able to take on some water. You can see here movement from the unsaturated zone, this arrow, it gets a little dashed because it's slowed down a lot, but it's not cut off completely. So water's still able to drip down, but this confining bed acts like a cap and makes something called a confined aquifer. An unconfined aquifer is the opposite. It's not capped by this confining bed. And so the unconfined aquifer is in connection, it's hydraulically connected with the water table. There's able for water to freely flow between the top of the water table to our unconfined aquifer because it's not capped by this low porous sediment. And so I started touching on this on the beginning, but recharge is a percolation of water into the aquifer. We're moving from the rain on the hillside, it's entering our unsaturated zone and then flowing downward because water wants to flow down from high elevation to low elevation. So it's flowing downward until it reaches our water table. And so that's called recharge. Groundwater recharge is water entering the aquifer. Discharge is the transfer of water out of the aquifer. And so I mentioned here that the water table is at a higher elevation on the side over here. And so this water is going to want to move towards the stream or lake, and that's going to discharge water out of the aquifer into the stream or lake and actually cause this river to flow. There's some places on Earth where you can find rivers just start out of the earth because it is an aquifer discharging water onto the surface. Water's exiting the surface pretty continuously. And if the water is being recharged, if the aquifer is being recharged, this water table can maintain the shape and maintain the flows within it. And it usually does. The weather previously, the rains that had happened previously or that caused this elevation, we can expect those to happen later on. And in some cases, that's not true, but for the most top part, this water table line is pretty consistent over years, unless we're discharging into withdrawals. Groundwater is very common for drinking. And so if people are taking a lot of groundwater out of the earth, this water table is going to decrease over time, like sucking water out through a straw from your glass. And so this is sort of a more graphical depiction of these subsurface zones. You have, again, your water table underneath a creek. It's slowly decreasing in elevation as it moves away from the head of the river. But this yellow sediment is an unconfined aquifer. And then you have aquitards or our confining beds, which are typically made out of clay. And if you remember from our sedimentary sizes, when we were looking at the sizes of sediments, clays are really, really fine. And so they're able to pack together a lot more and make these confining layers, which confine another aquifer called a confined aquifer. And so these wells are all tapping into different types of water, and they're going to display different hydraulic heads. This one on the far left is tapping into the unconfined aquifer, and it's going to display a water level that is matching our water table. The confined aquifer, this well right here, is tapping into the confined aquifer. That's going to display a water table that's representative of our confined aquifer because it's not the same as the water table of our unconfined aquifer. And then the same there's another confined aquifer in a different rock called basalt here. And the water level here is going to be even more different from all the three. So each one of these wells is tapping into a different reservoir all underground, but they're all distinct from each other and have their own elevations associated with them. So that's something to keep in mind as we move on through the course. It can be hard to think about this in like the Z elevation aspect of it all. It's not all connected like a big lake is. There's different parts to it, and that's formed by various porosities of sediments. So that concludes our video for today. Thank you, and I will see you next time.